Okay, so real quick, why don't you guys take a look at the board? Let's talk about a hypothesis. Okay, hypotheses, they're kind of iffy. Sometimes it's kind of hard to tell if a hypothesis is one or if it's not a hypothesis. Real quick way that you guys can find out if it's a hypothesis or not, two telltale signs. If it's a if-then statement, it's most likely a hypothesis. Remember, it doesn't mean it's necessarily a hypothesis, but it's most likely it's a hypothesis. If there's an if and then in it. What I mean by that is, for example, real quick example. You have, suppose I increase my bench by 20 pounds, probably my chest will get bigger. Is this a hypothesis?
Yeah.
Why? Testable, very good. This is a hypothesis because it's testable. Even though it doesn't have if or then in it, it's still testable. So it makes it a hypothesis. Now let's just say I switched out the words probably and suppose and put if I increase my bench by 20, then my chest will get bigger. Is that a hypothesis? Yes, because it's testable first of all. And a quick hint, if you're kind of iffy on it, it has the if and then statement in it. So always look for the hypothesis as being either an if-then statement, but more importantly, make sure it's testable. That's the key to identifying hypothesis. If it's testable, it can be a hypothesis. If it's testable, it's a hypothesis. Okay, so the universe began as a small space of massive density and exploded out from there. What is that?
Scientific theory.
The scientific theory. Why is that a theory? I know you guys have all heard the theory of the universe before, but why, when we break it down, why is that theory a theory? Well, you can't prove it. Very good. You can't prove it. You can't prove it. That's one part of the theory. What's another part? You can't prove it. What's another part of the theory? Why don't you guys just go ahead and think about that and read through number 3 and 4. So I'll give you guys about 2 minutes to read through all 1 through 4, and then we're going to go over it. Okay, so real quick. Okay, for numbers 2. We said that the universe began as a small space of massive density and exploded out from there. Okay, that is a theory. Number 1, because you can't prove it. And number 2, has there been lots of research on how the universe came to be?
Yes.
There's been a lot of research on how the universe came to be. Because of that research, even though we can't prove it, if you wanted to prove that, how could you prove that the universe exploded and came from nothing? You can't prove that. You can't grab the universe, ball it up, and blow it up again and see what comes out of that. You can't do that.
Doesn't mean go back in time.
You can't go back in time either. Just one makes a time machine. That's what's going to happen. But anyways, so the universe began as a small space of massive density and exploded out from there. The things that make a theory is that if it's studied intensively, and if it can't be proven, and if it helps explain something that's important that can't be proven. Okay, is it important that we know how the universe came to be? Or at least try and guess how it came to be? It's very important. I mean, we come from the universe, we want to know how this came to be, but we can't prove it. So the reason why it becomes a theory is because we can't prove it, because it's important, because we've done extensive research, data, we've done carbon dating, all this different stuff, just looking at the different layers of the Earth, trying to figure out how we came to be. The reason why we call it a theory is because we've done so much research on it. That's what makes it a theory. It helps explain something that is very important to us. Okay, number 3 says, this sample of spawn scum will contain Duglinac. Is that a hypothesis?
No.
Yeah.
Who said no?
No.
Is that not-
No, it's not a hypothesis.
Jordan says no. What do you say to it, Jordan?
I say it's a theory.
It's a theory. Gabby.
I say it's a theory.
Oh, this is a lot of people against Gabby. All right, this is what I want you guys to do. I want you guys to put your whiteboards. So let your whiteboards. Let's see who's right and who's wrong. Let's see who's right and who's wrong. Who's on Gabby's side?
No, both of them.
Swag, what's up?
Okay, so you got Nico and Jordan on one side. You got Gabby on the other. You guys pick your sides. Tell me if it's a
I'll take the
hypothesis.
side who holds it down.
Yeah, just write Jordan.
Tell me if it's a
How do you
hypothesis
spell your name?
or if it's a theory.
You can write the name of your
Write down the letter.
Write down the letter.
Alright, so
Told Jordan.
you're with Mr. Brown. Okay, so apparently
No, wait, I'm with Gabby.
you're with Gabby. Okay, a lot of people with Gabby.
What's the?
Okay, so who's with
Spell your
Gabby?
name.
Who's with Gabby? Raise their board. That means that you say it's a hypothesis. Raise it up and high. If you think it's a hypothesis or you pick A, you pick A, you're with Gabby, it's a hypothesis, raise your board. Okay, we got a lot of people for Gabby. Okay, if you think it's B and you're with Jordan and Nico, if you think it's a theory, go ahead and raise it. Not as much as Gabby.
Yeah, the one.
Okay, who's by himself on C?
I'm gonna get you answer.
Alright, let's see.
My bad.
We got Colvin for C. Okay, so
Off the man out.
those of you guys that are with Gabby are correct.
Yeah.
Hey, very good. Those guys with Gabby are correct. Very, very good.
I want to cut.
So real quick visual illustration. Okay, if it's testable, what makes that testable? What makes you think that you can come to a pond, pick up some water, and go test in the lab? Because it's possible. You can do that. You can actually just go to any lab or any pond, pick up some water, and test it for that specific bacteria. Okay, whether it has the bacteria or not, is that going to affect whether it's a hypothesis?
No.
Let's say we tested out that pond and it didn't have the bacteria we were looking for. Is it still a hypothesis?
Yeah.
It still is a hypothesis because it's testable. It's just that it wasn't a correct hypothesis because we said, hey, I think it's going to have this bacteria in it. We tested it out, turns out it didn't. It's still a hypothesis, but it's not a correct one. Okay, very good. Okay, number 4 says, cockroaches are afraid of lights.
No, fine.
I want you guys on your whiteboards to pick A, B, or C. Tell me what you guys think. We'll talk about that.
You can put a cockroach in the dark and turn the light.
Because when they turn on the light, it always runs.
That's what you want to say.
That's why I put it.
Okay, remember, don't show your answer until I ask for it. Whenever you get your answer, put your boards over so no one looks at yours.
I think
If
it's
you're going to try and steal some answers,
I don't have a marker. I
I
lied. I have one.
It's scared to be afraid of you.
No.
You're going to be.
so before you guys show your answers, be sure you put your answer board, flip it around. Don't show it to me. Don't show it to me yet. Flip it around so no one else sees it. Okay, so let's talk about this. Okay, so cockroaches. Are they afraid of light?
Yeah. Well,
I heard no. I heard we don't know. I heard.
Nobody every time you turn over the
You don't know what they're
can't talk.
you can't.
Okay, cockroaches can't talk. I heard that. Good point.
But it's testable because you can turn the light and shine a light on it.
That's true. It is
Some of them
testable.
walk around.
Thank you. Who just said that?
It is testable.
School.
Okay.
I'm
Some
going
of
to
them walk around in school.
Oh, yeah.
be.
And I heard light work.
My reason.
So,
Do what I want. My problem.
that's true. They do come out with the lights on.
So ha.
Okay, who knows a lot about cockroaches? Okay, so who has a lot of cockroaches in their house? Anyone have cockroaches?
You're not supposed to admit that.
Alright, so if someone can bring a cockroach to class next class period, maybe we can do something with that.
Let's see if I can get one.
I named it.
Okay, so. Okay, very cool. We actually, that'll work.
Crazy.
So, cockroaches. Okay, can we get a cockroach and get a light bulb? We can test that out, right?
Yeah.
So it is testable.
Go to
It's testable.
You're afraid.
Why is that? Why is that, Gabby?
Because you can't, like, you don't know what they do.
No. Okay, but right or wrong. Right or wrong? Do you not run from stuff that you are scared of?
Wrong.
That's why, just like your baby.
I do. Some people might
I'm
say
pretty sure if I brought a dog in here, if somebody was scared of a dog, they would run from it.
well, some people will just freeze up. Some people just freeze up.
If somebody come in the room,
Some people pass out.
So if you're, so if you're going to the bathroom, you sit big on out.
I said, what the hell you want? No.
Yeah. So we can test it out, but Gabby's on the right track. We can't. Who can talk to a cockroach? No one can really talk to a cockroach. You can talk, but he won't talk back to you.
Okay, I might.
I mean, you can talk to one, but it's not gonna talk back to
Like,
you.
get like this.
So with the cockroach, keep this in mind. Very, very important. On the tax test, or in the world of science, on the tax test or in the world of science, which includes chemistry, biology, this is what we think about feelings and emotions. We don't care about feelings or emotions. We don't care about that crap. Unless you talk about it, unless you can verbalize it. That means that I don't care if you get scared or you look like you're scared. I don't care if you look like you're angry. I don't care if you feel angry or feel scared. I can't tell. In the world of science, that doesn't count. You have to verbally tell me and give me feedback that you're scared, that you're angry, that you're afraid. I want to hear it verbally. I need to get some verbal communication or feedback. If you can't talk, I want you to write it out. I need some kind of feedback that I can check. In the world of science, we want feedback. We don't care about feelings. We don't care about emotions. All we care about is feedback on those feelings and emotions. Someone could look real scared. Let me see you guys. Who's got a scared face? What's a good example of a scared face? Who's got a good scared face? Okay, look at you. You see Michael? You see Michael? That's pretty good. Go ahead, Michael.
No, go ahead, my accent.
It was good. Ready for this? Go ahead. Okay, that's Michael being scared. A lot of people don't look like that when they're scared. Some people have their mouth gaping open. Some people just look like that, like they're just stunned. You can't tell if they're scared or not. The only way you can tell that they're scared, some people are just mad. Some people have eyebrows like this. I had a dude in school who everyone always thought he was just trying to front with people, but his eyebrows were just kind of stuck like that. He was a real nice guy. But if you guys know anyone whose eyebrows are kind of like this?
Yeah.
They just got angry looking eyebrows? Yeah, they can't help it. Their eyebrows just look like that because they're shaped like that. Yeah. Jordan.
Is a dog barking at you giving feedback?
You understand what he's saying?
No.
Who?
So that wouldn't be feedback, would it? Remember, we're looking for communication. Even though he's barking, he's giving out noise. It could be a friendly bark, it could be an angry bark. You can kind of tell yourself. Remember, as scientists, we don't care about that stuff. We want actual verbal communication back. Very good. Oh yeah, you can. You guys, as human beings, we can easily tell whether a dog's mad or not, right?
No.
I can't.
No, I swear on my mom. I've been petting a dog and it just bit me for no reason.
It's happened to me too, but maybe you just didn't provoke the dog, or
Maybe you had bacon smell.
Pet the dog in the head.
well, some dogs just like some dogs just crazy like that.
Dogs are bipolar.
Not really. How about Boulder? Catch me about my meds.
Who's talking?
That's true. So the only way you can actually find out if a dog or an insect is afraid is by isofront focus. So the only way that you can actually tell us something is afraid, whenever we deal with emotions, we don't care about that stuff unless you verbally communicate it to us. If a cockroach comes up to you and verbally communicates saying, hey, look, I'm scared of that light bulb, don't turn it on, that's verbal confirmation. Yeah, cockroaches can talk, but they can't talk. Crickets can't talk. Whatever any of that stuff, no one can really talk except in the movies. Okay, so cockroaches are afraid of lights. Is it A, B, or C?
B.
C.
B.
C.
Okay, it's testable, but it's scientifically testable.
Yeah.
Oh.
It's not scientifically testable. Very good. So that'd be C. The answer is C. Remember, you can test whatever you want to. Remember, in science, we don't care about emotions. We don't care about feelings. What we want is just the truth straight from the mouth of you.
No.
Really?
What?
I don't know,
There could be. There could be. That'd be interesting to look at.
C. Cockroach.
The cockroach whisperer.
What is that?
Okay, so real quick. Okay, the next question says numbers 1, 2, 3, 4, 5, 6, 7, 8. I want you guys to label or list down as many things as you would need to boil 100 milliliters of water. Go ahead and list 1, 2, 3, 4, 5, 6, 7, 8. Label as many things as you can think of on your paper that deal with boiling some water. You need a pot, but remember, we're in a chemistry lab. We don't have pots.
Does water count?
Water does count. Very good.
What? Juice.
If you don't got water,
Remember, we're not cooking here. We're boiling water. Just boiling water by itself. No hot dog, no noodles, no crock pots, no one beakers. I want to see if you guys can fill up 8 on your own.
Okay, so let's write stuff that we can boil.
What you need in order to boil water. I mean, just everything you need to boil water.
Oh.
If I say, hey, boil some water in the lab, in the chemistry lab, what are you going to need? You need a beaker.
Hold on, man. I'm not scared of water.
You need a beaker, you need water, of course. What else do you need? You need a flame. You need a flame. You need a thermometer. You need gas.
I thought we were supposed to make things that we could boil with water.
Oh,
Like eggs and water.
no.
This is in chemistry.
Remember, this is chemistry, not cooking. Okay, so, what else do you need? Very good. What would that be? Tongs. Some tongs. Even better. A stand. Stand. Even better. Got a stand. Got a ring. If I got a Bunsen burner and I'm burning it, am I gonna hold this? Am I gonna hold the tongs with this? Am I gonna hold this beaker with the tongs the whole time?
No.
Just sitting there, just trying to get it to boil? No. I want to set it somewhere. So get some wire mesh. Put it right here. Put the beaker at the top. Put the flame at the bottom. Get it lighted. Start heating up. That way I don't have to hold it. I mean, I can take this. I can, of course, I need the tongs, of course. But if I want to pick it up, take a look at it. But I don't want to have to hold it the whole time. Just trying to get it to boil. Hmm?
What is that called?
Yeah, there you go. That's good.
Oh,
Oven
what
mitt
about
or a.
striker to heat up?
We need the striker. Without a striker, without the flame, you can't have fire. What else?
What if you list more than 8? Is that okay?
If you listen more than 8, that's good. Even better. As long as you guys have 8. Does everybody have 8?
Yep.
So real quick, let me do a quick run through. You need a beaker. You need some water. You need a thermometer. You need tongs. You need wire mesh. You need a ring. You need a ring stand. You need gloves, goggles, apron, striker, Bunsen burner.
Doesn't that go in the flame?
Yeah, but when we're talking about equipment, we kind of want to break it down.
What's that thing that starts the fire? You know, like
Striker. Striker. You guys got it?
No, I need gas.
Yes. Okay, so, real quick,
wow.
go to the next question. It says, look to the front of the class, tell me what this is. For letter A, I want you guys to tell me what this is. What is this? This is letter A.
That's a flask.
It's a flask. This is letter A. This is a flask. This is a flask. What is this?
Beaker.
No, that's a...
Where do we put that at?
what does it start with?
E.
Erlenmeyer.
Perfect. Very good, Andrew. This is a Erlenmeyer flask. You spell it just like that. It's on the board. This is an Erlenmeyer flask.
It's what? B?
Erlenmeyer
Or
flask.
B?
This is a flask. This is A.
No.
B is the Erlenmeyer flask. So, you have 2 different types of flask. Regular flask, Erlenmeyer flask. Okay, this is the easy one. C, what is this?
Graduated.
Graduated cylinder. This is a graduated cylinder. Graduated cylinder. G-R-A-D-U.
I was about to say the same thing.
Okay, so, and for D, what is this?
Whoa.
Very good. This is a
No, I know something.
Burettes. Burette. That's how you spell it. That's it. Burettes. Okay. Cool. Okay, so for the next question, I want you guys to do something on your whiteboards. I want you guys to tell me the exact amount of water that is in that picture on your quiz. You write down the number. After you get your number, turn your board over. Then I'm going to ask you guys to show it at the same time. I'm looking for specifics. I'm looking for something very, very specific. I mean, I'm looking for decimal points. Feel free to use decimal points. I want you guys, I'm looking for a decimal number. I'm looking for a decimal number. I'm looking for, I want you guys to get as specific as you can as to what that is measured, or what the measurement of water is in that graduated cylinder. Give you guys about 20 seconds. Write it on your whiteboard and keep your whiteboard down until I ask you to do like that. Be sure you don't forget your units. What's the unit going to be in? Milliliters, very good. So it's going to be ml.
You know what the answer is?
Okay, so let me see what you guys got.
Oh, I messed up.
Nico. Very good. Go ahead and erase that. Close. Good, good. And you guys are close. Perfect. Christian, very good. Erase that. Close, close, close. Good. Perfect. Close, 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 close. Close, close. Perfect. 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 I like how it kind of starts shifting the correct answer when I get there. That's good.
I was right. I didn't erase it.
Okay, very good. Okay, so what I was looking for is, real quick, I want you guys to tell me. You guys take a look here at the board. Okay, if I have a graduated cylinder, whatever. I got a graduated cylinder. I have a liquid that's in it. Where am I going to measure it? Am I going to measure it at the very, very edge or at the very, very bottom? The meniscus, which is the what?
The curve.
Curve, the very, very bottom. Very good. So I want you guys to take a look at that picture one more time and tell me, what would it be? This is known as the meniscus. Anytime you measure anything in a graduated cylinder, you're going to measure it at the very, very bottom, which is known as the meniscus. Today you guys are going to be doing that. And the meniscus is terrible. I hate the meniscus. You guys will too, because you have to be very, very exact and precise with it. This is the meniscus. So ignore that. So right here, remember, you have to measure everything here at the very, very bottom. You guys are going to be doing that today in y'all's lab. You guys are going to hate the meniscus, but it has to be perfect. All right? So, on your guys' paper, I was looking for something like 32.9. Perfect, 32.9. I was looking for something like 32.9. That's all I was looking for, something for 32.9. Okay, so turn on to the back. Okay, number one says, one of the computer monitors has suddenly burst into flames. What should you do? What's the very first thing you should do if a computer monitor bursts into flames? You can tell the teacher if I didn't notice it, of course.
Fire extinguisher.
Okay, out of all these over here, what would it be? Okay, can you unplug a fire?
No.
If the computer's on fire, you unplug the cord. Is the fire going to go out?
No.
No. It's electrical fire. So let's take a look at B. Dump water on it?
No, it's electrical fire. Why do you?
Perfect. Very good. You can. Okay, C. Spray with fire extinguisher.
Yeah.
That'd be your answer. Very good. That would be your answer. Okay, number 2 says, you squirt yourself in the eye with an unknown chemical. What should you do?
Use the eye wash.
Use the eye wash station. Very good. And number 3 says, what could have prevented that?
Use some
Goggles.
Or
Goggles.
or not squirt it, so
That could have prevented it too. Some common sense could have done that. But we're talking about equipment, so that'd be goggles. Okay, number 4. I want you guys to take a look at number 4. I'm going to read it out loud. You guys read along with number 4. We're going to break this down. Okay, it says, while both acids reacted, H2SO4 was stronger than HCl. Okay, would that be part of the results or the conclusion? Tell me, does that sound like a conclusion or more like results? Does that sound like results or conclusion? Okay, let me say it like this. I'm going to reword number 4. Okay, H2SO4 reacted strongly, period. That's my sentence. HCl reacted very strongly, period. Would that be a result or a conclusion?
Result.
That'd be more of a result. If I say it like this, H2SO4 is stronger than HCl due to its reaction, that'd be more of a conclusion. That's me coming to a conclusion about it. You guys see the difference between that? It's kind of coming to a conclusion versus just stating what's the fact. Fact is, H2SO4 reacted, HCl reacted. They both reacted, that's a fact. My conclusion is H2SO4 reacted stronger than HCl. That's my conclusion, my own personal conclusion. Remember, you come up with conclusions based on facts. Okay, number 4, or number 5, is that a result or is that a conclusion? Is that a result or a conclusion?
Number 4 was a what?
Number 4 is a conclusion. But is number 5 a result or a conclusion? Why?
Because you said, well, that's because the last one said that, F, whatever it is, did not. So.
Yeah, it's a straight up fact. It is a result. It'd be part of the results because it's a straight up fact. Remember, you guys gotta trust your judgment on this. I'm trying to throw you guys off, but you guys are doing good. So number 5 is a result. 4 is a conclusion, 5 is a result. Remember, all 5 is stating is H2SO4, CaCO3, and HCl reacted. The other 2 did not. How could you change number 5 into a conclusion? You can make something up. You change it to a conclusion by saying, okay, the first 3 chemicals reacted, the second chemical did not. This means the first 3 chemicals are more volatile than the second 2 chemicals. Does that make sense? How I turn that statement or that result into a conclusion? You kind of come to a conclusion about it rather than just stating facts. Okay, cool. And we'll do more on getting you guys good with that. Okay, so real quick, let's get down to this question or this statement over here. I'm going to act out a little story for you guys to give you guys a visual on this. Because whenever I was in high school, I always hated reading through crap. Didn't like doing that, but I'm just going to illustrate this for you guys for the first time purposes, just so you guys get a good idea of what I'm looking for. Okay, so real quick, I'm going to tell you guys a story. Okay, my story is, this is what I do for a living. I staple papers for a living. I'm real bad at it. Whenever I staple papers, I staple about 2 papers a minute. So I grab my stapler, I grab some papers, staple 1, stand here, look at the paper, just waste my time, look at the next paper I'm going to staple, look back at the other paper, then I grab my next paper. I staple this one. After I staple that one, I staple about 2 papers a minute. I'm real slow. But I don't feel bad about that because I have 99 other coworkers that staple just as bad as me. So there's about 100 of us at a company that staple about 2 papers an hour. Or 2 papers a minute. Okay, so, yeah, it's a little bit too long. So we staple about 2 papers a minute. So me and about 100 other guys, or 99 guys. So, basically there's a solution for this. One guy comes up, his name is Mr. Smithers, he comes up with something called the special juice. Okay, so you get special juice. You got that special juice, this guy, Mr. Smithers has this special juice. You drink it, it's going to help you get better with stapling. So me and about half of the other guys, me and 49 other guys, we're like, all right, you know what, let's try this special juice. Let's drink it, see what happens, so see what works. So this is what happens. The boss splits us up into 2 groups. We have group A, which is me and 49 other guys, and group B, which is the other 50 guys. Our group, we take the special juice and we drink it. We drink the special juice. Okay, so we start stapling. We're still doing our own thing. The other 50 guys are just stapling too. We're stapling. By the end of the day, we look at the results. My group, Group A, which drank the special juice, we're now stapling only 1 paper a minute instead of 2. Yeah. Okay, Group B, guess what they're doing? They're still stapling 2 papers a minute. Nothing changed. So I want to ask you guys this. Out of this whole scenario, what was the fact or the game changer that was introduced into this scenario? What was something that was new that was introduced into the scenario? Before
the juice.
The juice. The juice was something that was new that was introduced into the scenario. Special juice. Okay, independent variables are always the thing that are introduced into scenarios. I want you guys to think about the independent variable as always being something, the new thing or the game changer that's introduced into a scenario. Is the game changer or is what changes things up whenever you add it into a scenario? So the independent variable would be that special juice. So that would be your answer for that question. That would be the independent variable. So the independent variable, it's always kind of icky, kind of iffy, kind of gray. But all I want you guys to look at for an independent variable is just take a look at it, see what was added into the situation. What was new? What was different? What was the game changer? That's what the independent variable will always be. And it's always going to be kind of, black and white. And we're going to do more exercises and more stories on that. But I want you guys to be able to just be able to know that the independent variable is always the new thing that's introduced or the game changer. Okay. Now, since that's the independent variable, the dependent variable depends on what? The independent variable. So we're on the right track. So the dependent variable is called dependent because it's dependent on the independent variable. The independent variable is the new thing that's introduced, or the game changer. The dependent variable is what changes, or what's affected. What's affected by the independent variable? Productivity, or the amount of staples or the amount of papers I stapled. That would be known as your dependent variable. Does that make sense? You introduce something that's new, the game changer, the juice, independent variable. Whatever this affects, whatever the independent variable affects, is what's going to be the dependent variable. And so that would be productivity, or the amount of papers I staple every minute. Okay, so, real quick. The next question is telling me, what is the control? Let's jump back up to number 6. What's the control? What does control mean? What does the control mean in an experiment?
It stays the same.
It stays the same. It's basically the thing or the group that stays the same. Group B. My group, Group A, we drank that special juice. Group B stayed exactly the same. So that means Group B would be the control. Okay, now there's a little gray spot between control and constant. Let's jump down to number 9. When it says identify the constant, what does a constant mean in the experiment? Consistent. Very good. It stays the same. So what are some elements of this whole scenario that just stayed the same? The task stayed the same. Very good. There's tons of constants. Start throwing them out there. Just name them. What are some elements of the scenario that stayed exactly the same? The task stayed the same. It's not like we ran a block. The amount of people in it. Very good. The amount of people. What else? The stapler we used. We all used the same stapler. We didn't get any high-power staplers or anything like that.
They have the same paper, right?
Have the same paper. It's not like we stapled more than 2 papers. They're all the same amount of paper, same thickness, same thing. What else? Same people involved. Very good. Same staples that we use in the same stapler. Very good. There's a lot of different constants that just never really changed. So, also one trick too is on the tax test. When you guys get a question like this, they're going to have a bunch of different, cause there's so many different constants. I mean, you could go on forever just naming constants. The room that we stayed in, that we all were stapling in, is the same. We didn't change our surroundings. That's a constant. There's so many different constants. So on the tax test, they're going to ask you, they're going to give you a list of a couple constants per A, B, C, or D. Always look for the one that has time in it. Time. Can you change time? That's always a constant. Remember, we're talking about productivity per minute. I can't stretch out time. I can't say, hey, this time I'm going to staple 3 in a minute. And I can't go 1, 2, 3. I can't stretch out time like that. It's always going to be 1, 2, 3, 4. It's always going to be like that. So time is always a constant, no matter what. In any experiment, time is always a constant. So go ahead and put time on your answer sheet. And be sure that anytime you guys take the tax test, look for the answer that has time in it. That's just a quick little tip or hint over there. Okay, cool. So you guys have 100% on this. Be sure your name's at the top. Before you guys pass it forward, that's what we're going to do. Essays, remember, essays are due at the end of class. That means that we're going to be doing a lab today. You guys may get small downtime. If you get downtime during the lab and you haven't finished up your essay, you might want to polish that up. Remember, essay on scientific method is due today at the end of class. So you might want to sneak in some time here and there. I'll be picking everything up at the end of class. So go ahead and pass your papers to the front. Put away your whiteboards, your markers, your rags. Put away all that stuff. And I'm going to tell you guys what we're going to do next. So guys, so we're putting this to the front. Make sure you got 100%. Go ahead and put away your whiteboards, your markers, your rags. Put away those items in your pillowcases. Be sure you got 100%. If you didn't get the answers first time around, go on the neighbor. this.
That's just liquid.
I'll get all
This is
this.
real funny. It's like a
Staple.
that was
Actually, you know what? I can just. Did you get that done? Alright, cool. Okay, so this is what you guys are doing today. Today is y'all's first technical lab. Real quick, before we jump into this, I want to ask you guys, little PA strips I gave you guys, what'd you guys do with those? You don't want to share what they did put in or put it in? Or?
I put mine in vinegar and milk.
Cool. Those are very two good choices. How did you know to put those in those food? Those are actually very good. Did you look it up or you just kind of know that?
Even the house.
Cool. That's perfect. What happened when you put it in the milk?
It sounds like a yellow grayish color.
A yellow grayish color. What about when you put it in the vinegar?
Red.
Red. So, basically those pH strips, they measure the acidity or how basic a certain substance is. Real quick, pH scale, it looks something like, it looks like this. Basically, you guys know what it looks like. You guys know what it's numbered from? What's the numbers on a pH scale? It's from what number to what number? Halfway there. 0 to 14. So it's 0 to 14. The closer it is to 14, the more basic it is. The closer it is to 0, the more acidic it is. The closer to being a base, it's going to be blue. Closer to being red, it's going to be an acid. So vinegar, you said that you dipped that little pH tab in vinegar, it turned red, like that. Take the rest of the class.
But if I have it.
Yeah, no, it's all right. So, Manisha, she dipped her pH tab in vinegar, it turned red. So you can conclude that it's an acid or that vinegar is acidic in nature. What happens if you get vinegar in your eye?
It didn't stay.
That's cool. You're all right. Yeah, so you can conclude that vinegar is acidic in nature. If you get vinegar in your eye, what happens? It burns, right? It's not going to blind you. It's going to burn. It's going to hurt. It's going to smell real bad. So that's kind of just an example. We're going to be going to the pH scale later on. We just kind of want you guys to get experience with that. Anybody else dip anything in any random solutions? Anything like that? All right, cool. And it was just for you guys to, and any results that you guys recorded, just keep that to yourself. That was kind of just more for you guys just to kind of get experience with that. Want to see what you guys would do with that. Okay, so real quick today. So you guys got a lab for today. This is actually y'all's first official lab. Take it very, very serious. And I'll tell you why. Because even though we're working with only water right now, I want to get you guys good with tactile, get you guys good with your motor skills, all that stuff. But take it very serious because all we're working with is water. But you still have to wear your goggles, you still got to wear your aprons. And we're going to be working on measurements today. I talked about the meniscus earlier. You guys are going to really be annoyed by this meniscus and you guys are going to hate it because probably first time around, most of you guys probably won't be on point with the meniscus. I had one student last period who actually got it right the first time around with the meniscus. I mean, right on point. And that was pretty cool because I was pretty surprised and they were really, really good. So they kind of set the bar for you. So I'm looking for you guys. You guys are a smart class. I'm looking for every single one of y'all to get it right on the first try. Let me show you guys what I mean. So with the meniscus, it's a real trick.